One thing I want you to notice when I'm working these problems is I'm going to work them down the page. I'm not going to work them side by side because in a unit, I can't remember if it's the next unit, yeah, it's the very next unit, you're going to verify identities and you have to work straight down the page. So if you're in a habit of working a problem side to side, don't do that on these. Okay, on this first one here, I want to try to simplify. So I'm trying to think to myself, is there a way that I can compare cotangent and cosecant? And if you'll look back at your Pythagorean identities, you'll see that 1 plus cotangent squared equals cosecant squared. So what I'm going to do, in place of this cosecant squared, I'm going to put 1 plus cotangent squared. So I'm going to substitute. So I'm going to have cotangent squared minus, and then I'm going to put this in parentheses. Because cosecant squared is equal to this, I can substitute that for cosecant squared. So I'm going to put 1 plus cotangent squared. So now I have cotangent squared x minus 1 minus cotangent squared x. So then I have cotangent squared x, subtract cotangent squared x, that cancels. And so this entire expression is just equal to -1. So those Pythagorean identities are going to be really helpful to substitute. Okay, let's look at this second one here. I want to try to find a way to compare cosine squared and cosecant. I know that cosecant is 1 over sine. So I'm going to think about the Pythagorean identity that would involve 1 and cosine squared. And I know that sine squared plus cosine squared equals 1. So if I move the cosine squared to the other side, that means that sine squared equals 1 minus cosine squared. So where I have 1 minus cosine squared, I'm going to substitute sine squared. So I have sine squared x times cosecant x, and I know that cosecant x is 1 over sine x. So now I have sine squared x in the numerator, and what that really is sine x times sine x. You don't have to write that out, but I'm just showing you. So now I have a sine in the numerator and a sine in the denominator that will cancel. So I have nothing left in the denominator. I just have sine x times 1. So the answer here would be sine x. So we use Pythagorean identity on both of those.